Hello, everyone. Good evening, good morning. Today, the session, it will be just as a continue. I want to highlight some points from the previous two sessions with Sadiq, and then I will speak about SQL a little bit. Maybe it will be this week, and next week it will be about SQL, and then I think we will move to another topic. If we are lucky, maybe we can finalize it this week only. The first point about the last two sessions, it's about the transfer learning. I want to mention something about transfer learning. Just let us consider the CNN structure in general. We have the conv layers, and then we have the fully connected layers. The transfer learning, let's say, just as intuition, why it is possible to happen on CNN, because the conv layer task in general, it's as we explained in the beginning of these 3 sessions or 4 sessions. The task of conv layer is to perform image processing or let's say computer vision tasks, which is just like edge detection or some other task related to the maybe grayscale somehow, whatever. So this filters is able, it will do the same whatever was the data set. There is no problem what is the data set. At the end, it's the same task, it will be applied. So once it's trained once, we are able to reuse it for other tasks. According to that, when we transfer learning, we are using this weight in the conv layers, and then for the fully connected layers, especially for the output layer, we are just retraining it. According to that, we will get the best result. This was the transfer layer in general. Now, what Mr. Sadiq did, this is here my app. He did something better. He considered the pre-trained conv layers. It's as initializing the weights, and then he also retrained the full neural network. Now, this will lead for better results, but let's say 70 or 75% of the time that we use these techniques, it's come with overfitting. What's the meaning of overfitting? That our neural network, it will be specific for our training set. Once we tried outside data sets for the same task, we will find that the accuracy, it will not be the same. There is many reasons for this. I'm not going to mention this. Maybe it will be assignment, or it will be something you can look for it. And for this reason, especially, we are using the early stopping. Now, early stop, it's a technique that we have to stop at the point where is the accuracy at the best. Now, Sadiq was using it just to be sure that it will never lose the accuracy. In fact, early stopping, it's used to prevent overfitting somehow. But we have to be careful with this technique that used by Sadiq. This is what I want to highlight. For transfer learning, we have 2 notebooks already. We show them. The first one from Sadiq using PyTorch, and the other one using TensorFlow. It's the original one that we start with it. Tom, please help me to push it to the repo. So when they pull it, it will be available for them. So you can check how to perform this. And here we have both cases. We have only transfer learning for the output layer, which is I use it. And there is something called dropout. You can see what it will do. And there is Sadiq method, which is initializing the weight with the pre-trained neural networks, and then retrain the full neural networks. And also we are using 2 different models. I'm using VGG19. He's using ResNet. ResNet, it will be better, but not sure. It's depend on the case. Also, both of them, it will be there. This is my ad for the previous session. Now I will move to the SQL. And here I want to highlight something. I will share my screen now. We are going, by the way, I noticed something, and yes, my bad. Congratulations, Gio. I know that, and each time I want to tell you, I forget. Okay, I'll share my screen now. Now, for anything related to the SQL, we will use initially this tool. It's called Microsoft SQL Server Management Studio. Now, because I'm more familiar with SQL Server as database engine, and more familiar with the TSQL. TSQL is the Transact SQL, which is the SQL implementation used in SQL Server. So I will use this one because I'm very much familiar with it. There is some concept which will be related to the SQL Server itself, but again, you have something like it on other SQL environments. So it will be easy for you to check according to that. But we will focus on the SQL Server. Now, the management studio, it's application, desktop application used to manage SQL servers and database engines. How to use it? First, we have to connect here to database engine. And we have the following authentication we have to provide. First, we have to determine the server. What is the authentication mode? We have either Windows authentication or SQL authentication. There is also some other authentication mode related to the cloud environments, but let's say, what's the difference between Windows authentication and SQL authentication? With Windows authentication, we are using the Windows user, the Active Directory user. With SQL authentication, we are using the login created on the SQL server. In general, we are using SQL authentication, but today to more faster, I will use the Windows authentication. If we use SQL authentication, we have to provide username and password to connect. Once we connect, this tree view, let's say, it will make our life easier because it will list all the databases built over this database engine. Now we are using SQL Express. SQL Express, it's a free version of SQL Server. It has almost all the needed features. There is something very advanced feature. It's not included. You have to go for the paid version. But the important difference, it's about the login count, how many logins you are able to create. But in general, SQL Express, it will be enough for us. And for, let's say, 80% of the tasks you might face, just like as individuals. Okay. Our database, we are going to use this database. And here, before going to the database structure, I want to highlight something. First of all, I want to mention brief definition about what is the time series analysis. Time series analysis in general, it's a machine learning task that deal with, let's say, phenomena that change over the time. So, for example, we can make time series analysis for the sales over the time. For example, for the last year or for the first quarter of specific year. We can say something related to the forecast. For example, the weather forecasting, if according to the season and which kind of seasonality might appear here. There is also some seasonal analysis might appear related to the, for example, maybe the sales, but depending on the holidays. So this analysis also it should be used. Now, the time series analysis, it's dealing with something called not data row or the data set, it's dealing with something called data point. And the data point, it will be in general, different or multiple rows studying the same case over a period of time. For example, maybe if we are talking about patient, the data point for us, it will be the patient visits of this patient, or the hospital visits of this patient over the last year. So according to that, maybe he will visit the hospital for 20 times. This 20 times, that means it's 20 row in our relational database that we might find it on the SQL server. It's considered as one data point for us. Now, if we want to make the time series analysis, we need multiple data points. In general, this is lead us for the following. Maybe most of the time, the time series analysis, it has a main difficulty. It's appear that the data size is not big. In general, we are dealing with the small data size. Now here we will speak today why I'm talking about time series, because today just I want to create some queries that might help us in collecting data on time series shape, for example, one reason. And the second, we want to generate some fake data before going there. I have this database. It's test database. It's considered patient, as we have patient. I will create database diagram to be easier for you to understand. So here only just okay. DBO does not exist. Just a minute. I have to fix something in the login. Okay, I'll just explain it like this. Here we are talking about a database. It has these tables, which is the following. The patient master, it's a table that containing patient information. It's general information about the patient. Here we will see right now, for example, we have the ID, patient name, date of birth, and nationality ID. Now, ID, it's identifier, it's the primary key of the table. Patient name, date of birth, nationality ID, it's a reference to another table to tell us what is the nationality of this patient. Nationality ID, it's called a foreign key, and it's nullable. It's able to be null. I'm going to first remove all the current values on another table. Now, this is the patient master. We have another table called patient nationality, which has the lookup values for the patient nationality. We don't have any nationality here right now or inserted. Okay. And then we have patient transaction. The transaction, let's consider it as visit to the hospital. Let's consider it as any kind of sales, anything that might appear according to the date. That means it's coming with the time and date stamp, okay, or time stamp. Now here, what we have, it's the following. We have ID, patient ID, the amount. We consider it as kind of receipt, the amount, and the transaction. This is the transaction table that we are going to use it to collect some data to come as time series. Now, in general, let's do the following just to get some facts. Select count ID from patient master. Now, when we run this query, it will tell us how many patients we have. We have in our database 366 patients, okay? Now, I'm going to remove all the rows from patient transaction, because this is right now, this will tell us how to build or how to generate some fake data to include it on this table. Okay, I remove all the transactions from the patient table, patient transaction table. And now I want to generate some fake data, some fake transaction to this patient. Now let's say I'm trying to check all the sales or all the transaction for the patient for the last 1 year. Now I already prepared something. It's mad idea, but yes, it can work. I prepare something table called days. Okay, just to generate the fake data. Select from days. Okay. Now here what I have only rows with the dates of this year, 2021. Why I need this one? Because I'm generating fake data that represent the sales for this year, 2021. So I just generate all the days in one table, and then I will use this to make kind of the transaction date, to use these dates. Now I will open this file that I have already prepared that contain the trick that we did for that. Now let's consider I'm going to generate 10,000 row. That means 10,000 transactions. And who will perform this 10,000 transaction? It's only the 366 patients that I already have them on the database. In this way, it's sure that we will get for each patient multiple transactions, And then this transaction, we can use it as example for time series analysis, just to collect data and check it. Now, to make a fair fake data generation, we have to consider the following. We don't need to make any PS related to the patient. So we need the chance of the patient ID to receive a transaction for all the patients, it will be the same. The probability is the same. So we need to find a randomized way to select the patient from our table. Here, randomized selection, not random from from let's say a numeric range. No, we need to select randomly from our table. The same, we are talking about the transaction date. When we are suggesting any transaction date, also we need to generate it randomly, just to forget any kind of PS. That means we are trying to shuffle the days and then generate the transaction date. And also, since we are generating fake data, the amount, which is the payment amount that's considered, also it has to be choose random. Now, we will see how to perform this. First, I declare this variable, which is I. It's integer because I will use it on the Y. And then I declare also another date time variable, just to assign the date, the transaction date to it. And I make I equal to 0. Now, since I want 10,000 row, so I'm running a while loop for 10,000 times. And then first task, I'm selecting a date time value from the days table randomly. How I'm doing it randomly? With using this function, the new ID. Now the new ID, it's a function that generates a unique value. It's GeoID value. This unique value, it consists of 32 characters for alphanumeric in general. Now this, it cannot be repeated. Now I'm not generating a new ID. That means I'm not generating a new GeoID value, but I'm ordering according to the new ID. So the SQL server, what will do? It will get the all days value, that 365 days that I have it on my table, and then assign a new ID for them. And this new ID, it's alphanumeric. That means it will not be, I'm sure it will not be repeated. And also I don't have any kind of control about the value coming to this new ID. So when I'm reordering the values according to this new ID, according to the alphanumeric order, it will come from the first, let's say if it starts with A or something, to the last. And then I'm choosing the top one, the first one. In this way, I'm sure I choose a random day value. Now, this is effective way to select randomly from a table, but also it comes with a huge cost in the memory. So for our case, when we are talking about 365 days, it's easy to perform. But if we have more than, let's say, the raw numbers, it's more than that, we have to think about optimize this. And maybe in the future, we will find how to optimize it. Now then, I have right now the day for this transaction. For the first transaction, it's already selected. Okay, now I will go for the insert statement. Insert into the table, which is patient transaction. It's our table. And we have the following value, patient ID, amount, transaction. Now, why I didn't mention on the insert statement the ID column, which is the primary key. I'm talking about maybe, by the way, it's nice to tell me if somebody is not familiar with relational database, so I can make, let's say, appendix video. I will push it to the YouTube just to tell you the basics. But I'm talking about that everybody has the basics. Only here to generate fake data and then group this data and collect them on, let's say, something similar to time series. Okay, so why I didn't use the ID in the insert statement for the patient transaction, sorry, simply because the ID first, it's a primary key, and then it's identity. Identity in SQL Server, that means it will be integer number and it will be auto-generated. During the design of the table, we are only selecting the start of this identity column, where it will start from 1 or from 2 or from 10. and what is the step of the identity. That means it will be increased by 1 or 2 or something like this, and then it will be auto-generated. According to that, when we are going to insert any value, any row in this table, we don't have to think about the identity column because it will be auto-generated. Now, patient ID, I need also to select the patient ID randomly, just like what I did on the days. So here we are not the typical, I'm going to write here the typical insert statement. It's like this. We have the table name, and then we have the columns, column 1, whatever. And then we have the keyword values. And this here we will add the values. And the values, it has to match the count of the columns. That means if I'm adding 3 columns, that means I will add 3 values. And also the data type has to be matched. If I'm adding date time, I have to be sure that the date time value will be there. So here value 1, whatever. Now this is one way to make to write the insert statement. The other way, it's the insert with the select. Here, it will be useful to insert one row or multiple rows, but your rows is coming from the database itself or from another database, and it has to follow some kind of condition has to be there, conditions have to be there. So how it will be, it's insert the same table name, and also we have the columns. And then instead of writing the values, we are going to write select statement, and the select statement, it has to have the same column count for that we added on the insert statement from table or multiple tables. We might make joins here, we might make ordering, and according to that, the insert will be perfect. So we are doing this insert, this kind of insert, which is with the select statement. And we will select, first of all, we will select patient. Okay, we have the patient master table. We give it a nickname, alias name, which is B. So we are using the pay.id, which is the patient ID, on the same way that we make it for the date. Here we assign the date, the random date we select into the variable D. Now, the b.id, we don't need to assign it. We are running on the select statement itself, but it's on the same way by using the new ID function, which is generating a random unique ID. And then by ordering this ID, we will be sure that randomly we will select the patient. Now, so we select this trick for 2 times, one for finding the date, and the other one is for finding the patient. And then we need to find the amount, which is the payment amount, and we have to generate it randomly. So we have the, I will explain it step by step, this comment here. First, we have the function rand. Rand is a function that giving us a random value between 0 and 1. Just like any other random or rand or random.rand in any other high-level language. It's doing the same. It's generating random value from 0 to 1. Now, if I multiply it with 3,000, I'm telling that this value, let's say, make it wider, not from 0 to 1. Here it's coming from 0 to 3,000. Okay, so I'm selecting random value from 0 to 3,000. Okay, as decimal, just to be sure about the format of the random value, because I need only 2 numbers after the comma in the decimal number. So that means 2 digital places, 2 decimal digital places. So in this case, I don't want to generate something like infinite loop under infinite count of digits after the comma. So I just make this to be sure about the format. And then casting it, also this cast function, just to be sure that we are casting this decimal to the suitable target. Now, what is the destination? It is the amount. Now, what is the amount? Amount is decimal also with the same format that we did. Sometimes we might have amount as another decimal format. So with casting, we will be sure also this it will meet the destination requirement. This is how I generate a random number between 0 and decimal value between 0 and 3000. Now here, I think you can imagine whatever Tom told us, it can be implemented here about what is the distribution of this value and how we can change it to study multiple cases from the SQL itself, and then we are able to call it from the programming language. Now, once we have this, just only don't forget to add the value to the counter and then finish. So if I run this one, I will generate 10,000 random transaction, the patient transaction table.
So guys, if you could take a minute,
Okay.
if you're at a good point, there's some excellent questions. I think.
Yes.
Yeah, go in the chat. Okay. I can read them to you, or you can open them. What do you prefer?
I'm opening. We have first, Jonathan. When you mention time series, are you looking for ARIMA, etc.? Will we have ERD for this? Jonathan, ARIMA, we might go for it, but I'm not mentioning anything related to that right now. I'm just studying how SQL might be helpful for that. Okay. Entity relation diagram. Yes, if ERD, it's an entity relation diagram, and this is what I was trying to do. But because this database, it's restored from another machine, so I don't have the security options ready. So that's why I didn't create it. But if you want to speak about how to generate entity relation diagram on SQL Server, I will show another example here in another database, which is the eClaim database. Okay, in the eClaim database diagram. Okay, and then in new, what we'll have here, we will have, it will come with all the tables. So I will add them one by one to the diagram. And then it will generate the entity relation diagram according to the relationship between the table that I already implemented. So entity relation diagram is that easy. And guess what? You are able to build the relationship from the diagram itself. That means you are able just to get this ID, for example, and go here to the hospital ID, and it will build a new relationship with the table, with that second table. But one thing it's important here, it's entity relation diagram from relational database point of view. So that means it will never accept, or you will never face a case that you have many-to-many relationship here. Here, it's already relational database, it's built. In entity relation diagram as designed, it will accept having many-to-many relationship, but you have to fix this issue when you implement it. Here, it's already implemented. Okay.
And then Kimberly's question is good, for sure.
Okay. I apologize if this was mentioned in the first few minutes, but are we creating complete mimic data set of random date and patient data based on existing variables so that we can predict something, transaction value, based on time series analysis. Okay, it's not about we can predict something. In fact, I was trying to go for something more real, not only, let's say, mimic data, just like this. In fact, here, it was here in the eClaim database, but I found that it's not good to mention it here just to explain the concept, and then maybe when we go to the real production, we will use the eClaim database. In the eClaim database, what I have real claims data, but I don't have the patient information related to that. So in case I want to make example about how this eClaim information can be used for time series analysis, I need at least to find what is the patient information related to them and also the physician information. So the same what we did right now, it can be used there, but only about one field, which is the patient. Now, the most important thing I'm showing today, it's about how to select randomly and how to generate random values in SQL Server. Now, forget about the use case that we mentioned already at all. Forget about it in the beginning. No problem. We are able to we know how to select randomly and how to generate random values. And I need 5 minutes at the end to tell you why this is important. Okay. Oh, my colleague semester was alive. Hitesh, why this? I need I need the explanation from you, Hitesh. Okay. Just checking. Okay. Okay, I think this is the question. Anything else?
Just a real quick high-level point to everyone. I think this is awesome, and I'll tell you why. I am not equal to Geith in SQL. I know enough SQL to do what I need to do. I would have never thought to create random data in SQL, but someone that's as good at SQL as Geith might not have thought to create fake data in Python. So whereas I tend to create the fake data in Python and push it to SQL if I want to store it that way, this is great to know all these methods you can use to create fake data directly in SQL using SQL. I love it.
Now, Tom, thank you. I want to show something, which is this three highlighted the 3 rows. Now, what I'm doing here, I'm trying to collect the data for all the patients, but that means the transaction data for all the patients that we already randomly generate. It's, let's say, summarized by month. That means it's grouped by monthly basis. That's for each month. And then I'm trying to find for each patient what is the total visits count and what is the total paid amount for each patient. And then I'm generating it and ordering it according to the date and to the patient ID. So let me run this. What we will find? We'll find that first, focus on this, please, patient ID. I will have patient ID 1 for 12 time, which is 12 months. And then I'm here by using this format and this function. It will return the month name for me when I'm using that, when I, let's say, converting the date time by this way, format, transaction date, month. Okay, MMM. Now, according to that, what it's doing, it's tell me for the first patient, how many the total visit was and how many the total paid amount was. The second, the third, etc. on monthly basis. So now just a little bit, let's say, consider if we are trying to find, to make anomaly detection or anomaly analysis or something. This is the data that we are looking for. We are looking for 12 on monthly basis. What is the average or what is the total paid amount? And then this can be used as a data set. And this is the simplest data set we can see. But for sure, we can make this query more complicated and to generate whatever data that we have according to the database that we are dealing with. The great thing, it's here. This is the query that we have. We are able to create something called store procedure. Create procedure, give it a name, and then run your query. This store procedure can be called always in any, for sure, any, let's say, high-level programming language environment, on Python, on .NET, whatever. So when we are talking about automating pipeline, and we have some method, maybe data preparation, if we are lucky, If we are really lucky, maybe the data preparation task, it will be related to the database 100% sometimes, but for sure it depends on the scenario that we are dealing with. I'm done.
That last part, that's great. So you could even send that as a stored string in from Python using SQL Alchemy or something like that, correct?
Yes,
Guy?
exactly. You didn't the query itself, it's already built, it's already stored on the database structure itself. For example, if I run this one, already we have it here. Just let us check here in the programmability for this database, store procedure. We have the procedure, it's already there, and it can be modified. You can fix it. Okay. Now, but since it's here, you are able to call it by passing the name of the procedure only. For sure, since it's a procedure, we are able to pass parameters. For example, if I want to make this at patient ID as int, okay, so we are able just to pass the parameter, and here I will tell him where patient ID equal to at patient ID. So,
oh, nice.
and this way I'm selecting for specific patient. So what I'm trying to say, somehow for some scenarios, it will be more effective and timely wise, and more effective on, let's say, even to collect the data, to make this, or to deal or to ask the database architect or database administrator for help. And a lot of data preparation tasks can be performed from the database itself.
Guy, could you briefly show us, so over here in the Object Explorer, expand your created procedure with the plus sign, and show us how you would bring it back using that. Yeah, right there.
Okay, so here, first I'm able to make modify. So it will open it and on the alter mode. So I'm able to modify. Now here from SQL Server itself, I'm able to make exec. Okay, so in this way, I'm running it from SQL Server. I don't know what environment I have here. I'm able to. I will prepare example and I will push it for how to use it with SQL Alchemy, and also another high-level example about how to use it with .NET C#.NET framework. So because it will be part of the database itself, and you are able to use it always. There is another kind of programmability appeared, which is the function, the functions in general, including functions returning scalar variable, that means returning integer or datetime or something like this, and also function that returning tables. Now, who is working on Oracle, it will be familiar with functions returning table value function more than store procedure. But in SQL Server, they like the store procedure concept more. This is the store procedure, just one thing. In general, we have something called views on the database, relational database, which is a kind of entity. We built it already, but it's collecting data from one or multiple tables. Now, this views, it's old concept, and it's still valid for all the database engines. But there is one problem with it. It's really allocating the size just like the table itself. That means the view, it will be from the database engine point of view, it's considered another table, even if the data is not there. But the store procedure, it's considered procedure. That means it will not be in the memory. It will not start consuming the resources until you call it. And once you call it for the first time, for SQL Server, it's building kind of execution plan. So the second time, it will be faster to call it. So this is the difference between the store procedure and the view in general.
Now, guys, let's assume you have a lot of stored procedures like this.
Yes.
That are they typically, I see where they're stored here in the under programmability, but
Yes.
in the general scheme of the database itself, is it stored in a special area of table where these are stored as strings or something?
There is, by the way, I didn't, I didn't run this previously. Yes, there is a kind, yes, of, there is the identification table for the, in general, for even for the full server, it has all of this information. That means we have the server here, and this server, it hosts multiple databases. One of them is the master database, which is we are not using here. The master database, it's contained the identification values for all tables, stored procedure, even schemas. Now, there is here something called DBO. DBO, it's the default schema for all the objects. This schema can be modified by the user. So all of this, it will be stored on that master database. And yes, if someone wants to look for a specific store procedure, he is able to select from that table until he finds the procedure that he wants. But
I get, oh, I was just going to say, I guess you just gave me a new insight into SQL and SQL servers in general, not Microsoft SQL Server. They're kind of like an operating system in a crude way. Because if you can create these procedures and store them and then go find them later, it seems like it's doing sort of an operating system role in a way.
I think you are okay, but the most important difference between the operating system and the database servers is database server is dealing with some rules you have to follow, then your data it will be reachable faster and more effective. So let's say operating system, it's there. You can search with the operating system. You can do whatever you want. But reaching to the values, to the rows, to the entities that you are looking for in SQL, in any SQL database, it's much faster than finding it on the operating system.
And now you said these, no matter which database you're in on the server, these procedures basically go to some central place on the master database. Is that accurate?
Yes, exactly.
And where would you find them using the Object Explorer?
This is the master database. Okay. The master database, it's something here you cannot find it. I think it will not be here. But when you run a query, there is this drop down. It's available databases, and then you can check the master. Now, I'm able to find the master database, but I'm unable to find how now, for example, to query about this store procedure because I didn't use this. I didn't use to do that. Okay. So this master database, it's containing all the information needed.
Okay.
And also there is some other indexes and some other values. It's already, even for this database, the test DB, it can be used. By the way, if there's something, it's not hard for me to back to this information, but the only problem, it's something that I didn't use it a lot. I make it one time, so I know that it's possible. But
yes,
to back to this information, it's easy to find it.
And the reason I ask, I could imagine being part of a bigger team and you don't want to go create a tool that someone's already created a good version of. You'd like to be able to go explore the tools that other people have made.
Okay, I will answer this in this way. When we are dealing with databases, that means operational database, something that we use it for daily transaction, not for analytic reason. In general, we have two kinds of adding programmability to the database. Either we add it on the server or we add it on the programming language level, on the environment or framework level. On the database server, we are adding it using store procedure. In general, for any table, in relational database, we have 5 kinds of store procedure it will be created. So any team, big team, already will build the table and add this store procedure with it, which is select all, select one, which is store procedure has the ID as primary key as a parameter, and we select one, insert, update, insert one, update one, and delete one. This 5 store procedure, in general, it will be in any designed relational database for a team, because the team will expect that this is what they will receive. Okay. Now the naming of the procedure, the naming schema, or how to name it, or whatever, it will be kind of common sense between the team themselves, so they will know how to do it. Now, the most important, it's what a new procedure, not belong to these 5 types, we created on the database for analytic reason or for something. How to understand this? In general, just like any other programming language, we are able to comment, we are able to add our notes, and to keep tracking it. So in general, will be useful for them, and for sure it will be a teamwork. That means there is another team member, another archiving on documenting method, that the other team member will get benefit from this. This is my last point. I didn't face any team that looking for specific procedure from the master or from the server properties itself. Always, it's easier for them to back for team colleagues, to the team members, to tell them exactly where is the suitable procedure that they are looking for. Now, this is from software point of view. Now, in data mining project, also there is the facilitator who's in the middle. He understands what the data analytic people needs, and he is part of the operational database design team, so he knows how the database is created. This is kind of, later we start naming this person as data engineer.
So when you created this one that you retrieved, there was a place you got it from, but correct me if I'm wrong, it seemed like it was very management studio dependent. That's
yes,
why I was
exactly.
asking.
Exactly.
Yeah. And so that's why I was asking all these things like, okay, if I'm dealing with SQL, even like at the command line, is there a way to go search for stored procedures that I might want to borrow?
All the objects, so procedure, views, tables.
Exactly.
And with the creation date, with the created user, all of them, it will be on that table. But really, I don't remember what's the name of the table.
That's
and
okay.
I don't. It's easy for me to make a search right now, but I am.
Well, because we're being really flexible with our class, if others have a strong interest in what I'm asking, you could continue next week if you wanted, but we could table it for a later class session also. For me, I find it interesting, and I could go learn it on my own, but if the rest of the class wanted to go a little deeper on, okay, we've created these stored procedures and we want to know where they're stored, and it's kind of like good stored procedure management practices is what I'm wondering about, because
Okay. Is it possible? So next week we'll do it like this: how to call this stored procedure from Python and from .NET. I will make 2 scenarios, and also how to manage the stored procedure and find the suitable stored procedure and find what's already stored there.
In fact, what you just said is how I do it. I do it from Python, but I would really like to see how to do it from SQL too. That's really good.
Okay. Perfect. Okay. Okay, so this is the next week it will be. And the next week, Ramadan will be finished, so I'm not going to wait for finalizing the session to go and eat.
Oh, and Kim has a question for you in the chat.
Okay. I'm going to do the chat. Which is more efficient from a processing perspective for large data sets? Creating procedures in SQL or Python? Wouldn't it be better to have a database data pulled into Python because you could use Colab. Now I'm assuming running SQL on your own computer versus on top. Okay, now again, I cannot say what is better, but I will assume the following. The SQL, the server, the database server, it's providing us with a very efficient way for data collection and data manipulation and in a fast and secure way. Now, to get the benefit from this in general SQL server, that means you will prefer to run the command on the server itself and then just collect the data on Python, in Python or in any high-level language. Now, what I'm thinking about, we have the server, the database server already is there, and then we have our application server, which has the executable code in another place, even if it's not the same machine, no problem with it. Now, either we are just asking, just call that server and let it make its task, because the database, once it's hosted on the server, it's not one file. It's, let's say, it's using all the resources of the operating system and the machine of that server to perform high-level data collection. So we are trusting this databases, which is already designed for serving a huge operating systems for banks, for any other kind of business. We are trusting them to collect the data for us, and then we are able to get it and use it on Python. So in this way, data injection, let's say data injection for our modeling process, it will be much faster. This is how I'm saying, if already we have a relational database that can provide us with the data. This is the first. The second point I want to mention, most of the time we have CSV file as a data set. Our data set will be on CSV file. Yesterday I was explaining to one friend about this. Sometimes for me it's easier just to import this CSV file into a relational database. It will come as one table, and then run the normalization process just to create a full database from it. And then maybe in this way, I will do the data cleansing during generating the database. So for me, sometimes it will be easier. That means what I mean when I say for me, that means with a person with, let's say, with a long time of experience with SQL programming. So this kind of people, they will prefer to do that. If I want to perform the data cleansing, okay, I will get my database into database, my data set into database, relational database. And since it's relational database and it has already very structured way for building the tables, already I will get the data clean somehow. So at least I will never get wrong format for the data.
Guys, if it's okay, I think next week we'll probably end up co-teaching a bit. And I think we're going to go deeper into the excellent, I see Kimberly's question as extremely important to the perspective of the students. And Kimberly, I think what Guy's trying to say, correct me if I'm wrong, Guy, we're creating an artificial situation here for education. In the grand scheme of things, which I think Guy was saying, and I agree, you're usually working with a big team where there's a lot of data that's been collected over years, maybe even decades. And you're usually, that database is old, it's being maintained, it's being updated, and the whole team's working very hard to share procedures and do good practices. But here, we're doing everything. We're creating our own database using SQL Server Express, we're creating our own schemas, we're loading it, then we're pushing data to it, fake or real, we're pulling data from it, all so that you get a feel for the overall process. But it's, Kimberly, it's at a toy level. And yet playing with things at a toy level is, as you could imagine, very good developmentally speaking. Anyway, I think, Guy, continuing this until, oh, good. Thank you, Kim. Until we beat it to death will be great. Okay, we probably should end, but I'm glad we're continuing because this was so good and so rich. Yes, Legos, exactly. It's very Lego-ish, as Dennis would say. He would be proud of us for using the Lego term. All right. Anything else, Guy, before we go?
I think we have to go.
Okay. Oh, I think,
The mentoring.
yes. See you in mentoring, guys.